Hello, in this lecture we will find out the value of line segment X. In the drawing we have triangle ABC. We know that side AB is equal to side AE. We also know that angle BAD equals to theta and angle EAC is also equal to theta. Angle BAC is equal to 90 degrees. Side BD is equal to 3 units. Side DE is equal to 7 units, and we want to find out the value of side EC that equals to X. Okay, so first of all we will define angle DAE as theta. Okay, so angle DAE equals to theta. This angle equals to theta according to our definition. And from point A we draw perpendicular to BC. So this angle equals to 90 degrees, and this angle is also equal to 90 degrees. We define the touching point of the perpendicular from point A and BC as point M. This point will be defined as point M, and then we will calculate the ratio between the areas of triangle BAD and triangle DAE. So the area of triangle BAD here the squared brackets is the sign for the area. It means the area of triangle BAD over the area of triangle ADE. The area of triangle ADE. This triangle will be equal the area of triangle BAD is equal to the base of the triangle, that is BD, times the height to the base, that is AM. AM is the height to the base because it creates 90 degrees with the base BD. So times the height AM over 2. So the area of triangle BAD equals to the base BD times the height to the base, that is AM, over 2, over the area of triangle ADE. What is the area of triangle ADE? The area of triangle ADE will be equal to the base of the triangle, that is DE, times the height to the base, that is AM. The height AM creates 90 degrees with the base DE, therefore AM is the height to the base DE. So times AM, it is the height over 2. I will repeat again. The area of triangle ADE equals to the base of the triangle, that is DE, times the height to the base, that is AM, over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And what is left of this expression after we cancel 2? What is left is actually BD times AM over DE times AM. So here we have AM in the numerator and AM in the denominator, so AM will get cancelled, and we left only with BD over DE. Okay, but BD equals to 3 units according to what is given us in the question, and DE, it is given us in the question that it equals to 7 units. So in conclusion, we found out that the area of triangle PAD over the area of triangle ADE equals to 3 over 7. In the next step, we will calculate the areas of triangles ADE and AED in a different way. In the second calculation of the areas, here we will take AB as the base of triangle ABD, times the I to the base. The I translates 90 degrees with the base AB, therefore from point D we will draw perpendicular to AB. So this angle equals to 90 degrees, and this angle is also equals to 90 degrees, and we will define the touching point of the perpendicular from point D and AB as point O. So actually line segment OD is the height to the base, therefore line segment OD is perpendicular to the base AB, therefore line segment OD is the height to the base, that is to say we define it as edge 1. Okay, so the area of triangle ABD will be equal to the base AB times the height to the base times the height to the base, that is edge 1, over 2. I will repeat again. The area of triangle ABD equals to the base, that is AB, times the height to the base, that is actually H1 over 2. Okay, likewise we will find out the area of triangle ADE. Here the area of triangle ADE will be equal to the base of the triangle, that is DE. Here we will take the base of triangle ADE as AE. AE will be equal to the base of the triangle AED. So it is AE times the height to the base AE. So from point D we will go perpendicular to AE. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees. And dk will be defined as the height to the base AE, therefore we will define it as H2. Okay, so the area of triangle AED will be equal to the base AE times the height to the base, that is H2 over 2. I will repeat again. The area of triangle AED will be equal to the base AE times the height to the base, that is H2 over 2. So here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled. And what is left from this expression after we cancel 2, what is left? It is actually AB times H1 over AB times H1 over AE times H2. But because of the fact that it is given us the question that AB equals to AE, then AB over AE will be equal to 1, so AB over AE will get cancelled. So in conclusion, we found out that according to equation number 1, 3 over 7 equals to H1 over H2. So in the next step, we find out the values of H1 and H2. Okay, so here we have the right triangle AOD. In the right triangle AOD, AOD, sinus theta will be equal to H1 over AD. Sinus theta will be equal to H1 AD. So sinus theta equals to H1 over AD. Here we will multiply this equation by AD and we'll get that H1 is equal to AD times sinus theta. So I can write here that H1 equals to AD times sinus theta. Okay, so we found out that H1 equals to AD times sinus theta. In the same way, we find out the value of H2. We will focus on the right triangle A. We define this point as K, so we focus on the right triangle ADK. In the right triangle ADK, here sinus alpha will be equal to H2 over AD. Okay, sinus alpha equals to H2 over AD here. So here we found out that in the right triangle ADK, sinus alpha equals to H2 over AD. We will multiply this equation by AD, and we will get that H2 is equal to AD times sinus alpha. So can I tell that H2 is equal to AD times sinus alpha? So here we have AD the numerator and AD the denominator, so AD will get cancelled. So in conclusion, according to equation number 1, we found out that 3/7 is equal to sinus theta over sinus alpha. Okay, according to equation number 1, 3/7 equals to sinus theta over sinus alpha. Here we will cross multiply equation number 1, and we get that according to equation number 1, 3 times sinus alpha equals to 7 times sinus theta. Here we find out the value of angle alpha. Actually, according to the drawing, we know that angle BAC from one side it equals to 90 degrees. It is given us the question. Okay. So from one side, angle BAC equals to 90 degrees according to what is given us in the question. But from the other side, angle BAC, the big angle BAC equals to theta plus alpha plus theta, that is actually 2 theta plus alpha. So from this equation, 2 theta plus alpha equals to H2 equals to, from this equation, 2 theta plus alpha equals to angle BAC equals to 90 degrees. We will derive that 2 theta plus alpha equals to 90 degrees. Here we will subtract 2 theta from this equation, and we get that angle alpha is equal to 90 degrees minus 2 theta. Okay. Again, angle alpha equals to 90 degrees minus 2 theta. So now we can substitute angle alpha in equation number 1 here by 90 degrees minus 2 theta. So we'll do it now, and we will get that three times sinus alpha, and alpha equals to 90 degrees minus 2 theta. Okay, 3 times sinus alpha, and alpha equals to 90 degrees minus 2 theta. That equals to 7 times sinus theta. So here we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. According to this trigonometric identity, we get to, that the value of sinus 90 degrees minus 2 theta is equal to cosine 2 theta, and therefore we can substitute 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. We will do it, and we will get that according to equation number 1, shown 3 times sinus 90 degrees minus 2 theta is cosine 2 theta. That equals to 7 times sine theta. So here we have a trigonometric identity for cosine 2 theta. Actually, the value of cosine 2 theta is equal to 1 minus 2 sine square theta. So according to this trigonometric identity, we get that 3 times cosine 2 theta is actually 3 times 1 minus 2 sine square theta. Here it is 1 minus sine square theta, that equals to 7 times sine theta. We will open the brackets of equation of this side of equation number 1, and we will get that three times 1 is 3, and 3 times minus 2 sine square theta is minus 6 times sine theta, sine square theta. And it equals to 7 times sine theta. So here we will enter equation number 1, 6 times sine square theta, and we will subtract 3, and we get that according to equation number 1, six times sine square theta plus 7 times sine theta and minus 3 equals to 0. So here we have a quadratic equation. The missing variable in this quadratic equation is sinus theta, and the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here the coefficients and the variables a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to a special formula for x. It is actually x equals to minus b plus minus square root of b squared minus 4 times AC over 2a. Okay, and in our specific quadratic equation, the variable that we are looking for is sinus theta, so x will be equal to sinus theta. The coefficient a will be equal to 6 units. The coefficient b will be equal to 7 units. And the coefficient c will be equal to minus 3 units. Okay. So now we will put the data inside the equation for x in order to find out the value of sinus theta that is actually equals to x. So here we have x that is actually equals to sinus theta, that equals to minus b. B equals to 7, so minus b will be minus 7, plus minus square root of b squared. B is 7, so b squared is 49. So b squared is 49. Okay, so it is b squared is 7 squared, that is 49, minus 4 times a is 6, and c is minus 3, over 2a. 2 times a is 6, so it is 2 times 6. So we got that sinus theta is equal to minus 7 plus minus, here we have 49, minus 4 times 6 is minus 24, minus 24 times minus 3 will be equal to 72. So in conclusion, we found out that minus 4 times AC equals to plus 72. All divided by 2a, 2a, 6, so 2 times 6 is 12. So I actually found out that sinus theta equals to minus 7 plus minus 49 plus 72 is 121. So over 12. So we found out that sinus theta equals to minus 7 plus minus square root of 121 is 11 over 12. So here we have two solutions that are possible for sinus theta. the first solution for sinus theta will be that sinus theta is equals to minus 7 minus 11 over 12, and the second solution for sinus theta is that sinus theta is equal to minus 7 plus 11 over 12. Okay, so we found out that sinus theta equals to minus 7 plus 4 over 12, according to the second solution for sinus theta. We'll focus on the first solution. So we found out that sinus theta is equal to minus 7 minus 11 is minus 18, and minus 18 over 12 is minus 1.5. So we found out that sinus theta is equal to minus 1.5, and so actually, because of the fact that sinus theta can accept values between minus 1 and 1, and here minus 1.5 is less than 1, so it exceeds the range of the values that sinus theta can accept. Therefore it is incorrect answer, because sinus theta can never be equal to minus 1.5. So we cancel this option, this solution, and we focus on the second solution, that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4, and 4 over 12. Here we divide both the numerator and the denominator by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay. We found out that sinus theta equals to 1 over 3. In the next step, we'll focus on triangle ABE. So I will copy this triangle in a new page, and we will analyze triangle ABE. So a triangle ABE is an isosceles triangle because of the fact that it has two sides that are equal to each other, according to what is given us the question. AB equals to AE, therefore triangle ABE is an isosceles triangle and AM is perpendicular to BE, therefore AM is the height to the base BE. So first of all I will mention that BE is the base of the triangle. Side BE of triangle ABE is the base of the triangle. And AM is the height to the base. AM is the height to the base. To the base BE. And actually have rule number 1. According to rule number 1, the height to the base in an isosceles triangle bisects the base. Write it down, the height to the base the height to the base of an isosceles triangle bisects the base. So in our specific triangle, the isosceles triangle, triangle ABE, we have the height AM to the base BE, and according to rule number 1, the height AM bisects the base BE, that is to say, BM equals to ME according to rule number 1. BM is equal to ME according to rule number 1. So if we define BM as Y, then from this equation Y equals to BM equals to ME, we will get that ME is also equals to Y. So ME is also equals to Y. So what is the value of BE? The value of BE, from the drawing, you can see that BE equals to BM plus ME from one side, but BM equals to Y and ME equals also to Y, so it equals to 2, BE equals to 2Y. So from one side BE equals to 2Y, but from the other side from the drawing you can see that BE equals to BD plus DE. I repeat again, BE equals to BD plus DE, but we know that BD equals to 3 units and DE equals to 7 units. So in conclusion, we found out that BE equals to 10 units. So I'll repeat again, from one side BE equals to 2Y and from the other side BE equals to 10. So from this equation 10 equals to BE equals to 2Y, we will conclude that 2Y equals to 10. We will divide this equation by 2 and we will get that Y equals to 5. So found out that Y equals to 5 units, but according to our definition BM equals to Y and Y equals to 5 units, so BM will be also equal to 5 units, and because of the fact that ME is also equals to Y and Y equals to 5 units, therefore ME will be also equal to 5 units. So I can write here that BM equals to 5 units and ME is also equals to 5 units. So in the next step we will prove the triangles EAM, the right triangle EAM and the right triangle AMB can go into each other. Again, we will prove that the right triangle AME can go into the right triangle ABM. So why those two triangles can go into each other? First of all, it is given as the question that AB equals to AE. Again, AB equals to AE according to what is given as the question. Repeat again. AB equals to AE according to what is given as the question. We just right now found out that BM equals to ME equals to 5 units. So BM equals to ME equals to 5 units, and we also have here a common side that is AM. AM equals to itself. It's a common side that belongs to both triangles. So we actually proved that the right triangle ABM can go into the right triangle AME according to side rule. I'll write it again. Here, triangle AME congruent, this is the sign of congruent, to triangle ABM according to side rule. We actually proved that all the angles of triangle ABM can go into all the angles of triangle AME. Therefore, we prove that those two triangles can go into each other according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BME is equal to angle MAE. I repeat again, angle BME, so it is angle BAM is equal to angle MAE. I'll repeat again. We will prove that angle BAM equals to angle MAE according to the rule that corresponding angles in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding angles, that is to say BAM and AE, will be equal to each other. Okay. So angle BAM equals to angle MAE. So if we define angle BAM as Z, so according to our definition, angle BAM equals to Z. So from this equation, Z equals to angle BAM equals to angle MAE, we will conclude that MAE, angle MAE, is also equals to Z. So we actually found out that angle MAE equals to Z, that angle BAM equals to Z according to our definition. So what is the value of angle BAE? From one side, angle BAE equals to angle BAM So from one side, angle BAE equals to angle BAM plus angle MAE. angle BAE equals to angle BAM plus angle MAE, but angle BAM is equal to Z, according to our definition, and angle MAE is also equal to Z. So in conclusion, we found out that angle BAE equals to 2Z from one side, angle BAE equals to 2Z from one side, and from the other side, angle BAE it is actually equals to theta plus alpha. Angle BAE equals to theta plus alpha. So from this equation, theta plus alpha equals to angle BAE equals to 2Z. We will conclude that theta plus alpha equals to 2Z. We will divide this equation by 2, and we will get that angle Z equals to theta plus alpha over 2. So actually angle BAM that equals to Z will be equal to theta plus alpha over 2. And angle MAE that is also equals to Z will be also equal to theta plus alpha over 2. So I write it down here that angle BAM is equal to theta plus alpha over 2. And angle AME, angle MAE is also equals to theta plus alpha over 2. So this angle MAE is also will be equal to theta plus alpha over 2. So in the next step, I will draw the right triangle AEME in a new page, and we will analyze triangle MAE. The right triangle MAE. We just right now found out that angle MAE equals to theta plus alpha over 2. So I write it down, theta plus alpha over 2. ME is equal to 5 units. We already found out that ME equals to 5 units. So this is the right triangle MAE or MAE. We know that ME equals to 5 units, angle MAE equals to theta plus alpha over 2. We will define side AM as H. Again, AM equals to H according to our definition, so we can write here that AM equals to H. And we create equation number 1 that states that tangent theta plus alpha over 2 equals to ME over AM. But ME equals to 5 units and AM equals to 8. So in conclusion, we found out that according to equation number 1, tangent theta plus alpha over 2 equals to 5 over H. So I'll repeat again. According to equation number 1, tangent theta plus alpha over 2 equals to 5 over H. In the next step, I will copy triangle AMC in a new page and we will analyze the right triangle, triangle AMC. Side AM equals to H according to our definition. And what is the value of angle MAC? From the drawing, it is very easy to see that the value of angle MAC is actually theta plus alpha over 2 plus theta. Again, the value of angle MAC equals to theta plus alpha over 2 plus theta. And what is the value of MC? You can see it is very easy to see from the drawing that the value of MC is ME plus EC. I will write it down. MC equals to ME plus EC. But ME equals to 5 units and EC equals to X. So in conclusion, we found out that MC equals to 5 plus X. So this is the right triangle AMC, and the only missing angle here is angle ACM. We'll find out the value of angle ACM according to the rule that the sum of the angles in any triangle is equal to 180 degrees, and especially in triangle AM, in triangle ACM, here the sum of its angles must be equal to 180 degrees. So here angle MAC plus 90 degrees plus angle ACM, in total they must be equal to 180 degrees. So I will write it down that angle MAC, this angle plus 90 degrees plus the angle that we are looking for is angle ACM. In total, the sum of those three angles must be equal to 180 degrees. We will subtract 90 degrees from this equation, and we'll get that angle MAC plus angle ACM equals to 180 degrees minus 90 degrees is 90 degrees. Here we will subtract angle MAC from this equation, and we'll get that the angle that we are looking for, that is to say angle ACM, equals to 90 degrees minus angle MAC. Okay? But we have already found out that angle MAC equals to theta plus alpha over 2 plus theta. So I write it down. So angle ACM is equals to 90 degrees minus angle MAC, that is actually theta plus alpha over 2 plus theta. But we know that angle BAC from one side it equals to 90 degrees. It is given us the question. But from the other side, angle BAC equals to theta plus alpha plus theta. That is to say it equals to 2 theta plus alpha. From this equation, we will conclude that 90 degrees is equal to 2 theta plus alpha. Therefore, we can substitute 90 degrees by 2 theta plus alpha in this equation. So we'll do it now, and we will get that angle ACM, the angle that we are looking for, equals to 90 degrees, that is 2 theta plus alpha, minus theta plus alpha over 2 plus theta. So we actually substituted 90 degrees by 2 theta plus alpha, and we got this equation that states that angle ACM, the angle that we are looking for, equals to 2 theta plus alpha minus theta plus alpha over 2 plus theta. We will open the brackets on this side of the equation and we will get that angle ACM, the angle that we are looking for, is equal to 2 theta plus alpha minus theta plus alpha over 2, and we open the brackets here, so the plus sign will become to minus because we add minus before the brackets, so it will be minus theta. So here the angle that we are looking for, that is actually angle ACM, will be equal to 2 theta minus theta is theta, so we have here theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So the angle that we are looking for, that is to say angle ACM, will be equal to theta plus alpha over 2. Now I'll copy the right triangle ACM here, and we will put the value of angle ACM inside the triangle. So we have the right triangle MAC. We just right now found out that angle ACM equals to theta plus alpha over 2, MC equals to 5 plus X, AM equals to H. So here, this is the right triangle AMC. So here we will get that tangent theta plus alpha over 2, according to equation number 2, tangent theta plus alpha over 2 will be equal to AM over MC. AM equals to H, MC equals to 5 plus X. So in conclusion, we found out that according to equation number 2, tangent theta plus alpha over 2 is equal to H over 5 plus X. But according to equation number 1, we have already found out that tangent theta plus alpha over 2 is equal to 5 over H. In the next step, we will create equation number 1, that is the combination of equation number 1 with equation number 2. So actually, according to equation number 3, tangent theta plus alpha over 2 will be equal, according to equation number 2, it equals to H over 5 plus X, while according to equation number 1, tangent theta plus alpha over 2 equals to 5 over H. Okay, so as you can see, equation number 3 is combination of equation number 1 with equation number 2. In the next step, we will calculate the value of theta plus alpha over 2. So what is the value of theta plus alpha over 2? The value of theta plus alpha over 2 will be equal to theta plus alpha, and alpha, we already found out that alpha equals to 90 degrees minus 2 theta. All divided by 2. We'll open the brackets and we'll get the theta plus 90 degrees minus 2 theta over 2 equals to 90 degrees. Theta minus 2 theta is minus theta over 2. So it is 90 degrees over 2 is 45 degrees minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 is equal to 45 degrees minus theta over 2. So you already know if alpha equals to beta, then tangent alpha will be equal to tangent beta. So here tangent theta plus alpha over 2 must be equal to tangent 45 degrees minus theta over 2. Here we have trigonometric identity for the expression of tangent 45 degrees minus theta over 2. According to the following trigonometric identity, the value of tangent x minus y will be equal to tangent x minus tangent y over 1 plus tangent x times tangent y. So we use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. According to this trigonometric identity, we will get that tangent 45 degrees minus theta over 2 equals to tangent 45 degrees minus tangent theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. We know that tangent 45 degrees is 1, so write it down that here we will get that this expression is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So the only thing that is left to do here is to find out the value of tangent theta over 2. In order to find out the value of tangent theta plus alpha over 2, we'll find out the value of tangent theta over 2. We have actually trigonometric identity for tangent theta over 2. According to the following trigonometric identity, the value of tangent theta over 2 it is actually equals to sinus theta over 1 plus cosine theta. Okay, We have already found out that sinus theta equals to 1 over 3. We have already found out that sinus theta equals to 1 over 3. We have the trigonometric identity that states that sinus theta plus cosine sinus squared theta plus cosine squared theta equals to 1. Here we subtract sinus squared theta from this trigonometric identity, and we get that cosine squared theta equals to 1 minus sinus 1 minus sinus squared theta. We take a root out of this equation and we will get that cosine theta equals to the square root of 1 minus sine squared theta. So actually cosine theta equals to square root of 1 minus sinus squared theta, but sinus theta equals to 1 over 3, so sinus squared theta will be equal to 1 over 9, so it is 1 minus 1 over 9. That is actually equals to 1 minus 1 over 9 is 8 over 9. And the square root of 8 is 2 times square root of 2, and the square root of 3, the square root of 9 is 3. So in conclusion, we found out that sinus theta, that cosine theta is equal to 2 times square root of 2 over 3, and we already found out that sinus theta is equal to 1 over 3. So now we can find out the value of tangent theta over 2. According to this trigonometric identity, tangent theta over 2 equals to sinus theta, and sinus theta is 1 over 3 over 1 plus cosine theta. And we just right now found out that cosine theta equals to 2 times square root of 2 over 3. Here we will multiply 1 by 3, and then we will divide it by 3 in order to have a common factor with this expression, and we will get that 1 over 3 plus 2 times square root of 2 over 3. Here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled, and we left only with 1 over 3 plus 2 times square root of 3. In conclusion, we found out that tangent theta over 2 equals to 1 over 3 plus 2 times square root of 3. So here we will simplify this expression. 1 over 3 plus 2 times square root of 3 equals to, here we will multiply this expression by 3 minus 2 times square root of 3, and then we will divide it by 3 times minus 2 3 minus 2 times square root of 3. So in the denominator we have 3 minus 2 times square root of 3. In the numerator we have 3 minus 2 times square root of 3. And in the denominator we have expression that is very similar to the algebraic identity that states that a plus b times a minus b equals to a squared minus b squared. Here a equals to 3, so a squared is 3 squared, 3 squared is 9, minus b squared. B equals to 2 times root of 3, so b squared is 8, so it is minus 8. So in conclusion, we found out that this expression equals to 3 minus 2 times root of 3. That is to say, we actually found out that tangents theta over 2 is equal to 3 minus 2 times square root of 3. Now we can put this value inside the equation of tangent theta plus alpha over 2, and we find out the value of tangent theta plus alpha over 2. We have already found out that tangent theta plus alpha over 2 is equal to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. So it is actually equals to 1 minus tangent theta over 2 is 3 minus 2 times square root of 3 over 1 plus tangent theta over 2 is plus 3 minus 2 times square root of 3. Here we have 1 minus 3 is minus 2, and we have here minus and minus is plus. So it is plus 2 times square root of 3 over 1 plus 3 is 4 minus 2 times square root of 3. So we have here 2 times square root of 3 minus 2 over 4 times square root of 3, 4 minus 2 times square root, 2 times square root of 3. So here actually here we have the expression itself. It is actually 2 times square root of 2, 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 here also 2 times square root of 2, it is also 2 times square root of 2, so tangent theta equals to 3 minus 2 times square root of 2. So here we have 3 minus 2 times square root of 2, 2 times square root of 2, and here also 2 times square root of 2. Okay, so here we will take 2 as a common factor from the numerator, and we will get that inside the brackets we will have square root of 2 minus 1 over, from the denominator we will take 2 times square root of 2 as a common factor, and inside the brackets we will have 2 square root of 2 minus 1. So we have square root of 2 minus 1 in the numerator and square root of 2 minus 1 in the denominator. So square root of 2 minus 1 will get cancelled. We have 2 in the numerator and 2 in the denominator. So 2 also will get cancelled. It will be left only with 1 over square root of 2. So in conclusion, we found out that the value of tangent theta plus alpha over 2, it is actually equals to 1 over square root of 2 But according to equation number 3, we found out that tangent theta plus alpha over 2 equals to h over 5 plus x, and it is also equals to 5 over h. And we just right now found out that tangent theta plus alpha over 2 equals to 1 over square root of 2. So from this long equation, we will derive that 5 over h equals to 1 over square root of 2. We can write down that 5 over h equals to 1 over square root of 2. We will cross multiply this equation, and we get that h equals to 5 times square root of 2. We found out the value of h. From this long equation, we will derive this equation that h over 5 plus x equals to 1 over square root of 2. So I'll write it down. The equation is h over 5 plus x equals to 1 over square root of 2. So here we'll substitute h by 5 times square root of 2, because h equals to 5 times square root of 2. We'll do it now. We will get that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2. Here we will cross multiply this equation, and we will get that 5 times square root of 2 times square root of 2 equals to 5 plus x. Here square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we found out that 10 equals to 5 plus x. Here we subtract 5 from this equation, and we get that x equals to 5 units, or x that equals to CE or EC equals to 5 units. So the answer to the question is the x, line segment x here, that is actually equals also to EC, is equal to 5 units. In the next step, I will summarize the lecture. Okay, so we actually have here triangle ABC. We know that AB equals to AE. We also know that angle BAC equals to 90 degrees, angle BAD equals to theta, angle EAC also equals to theta, BD equals to 3 units, DE equals to 7 units, and we want to find out the value of EC that equals to x. So first of all, we define angle DAE is alpha, and from point A we draw perpendicular to BC. So this angle equals to 90 degrees, and this angle also equals to 90 degrees. We define the touching point between the perpendicular from point A to BC as M, and then we calculated the ratio between the area of triangle ABD and triangle ADE. So we have here the area of triangle BAD equals to the base of the triangle that is BD times the height to the base that is AM over 2. The height must create 90 degrees with the base, and indeed AM creates 90 degrees with the base BD. So the area of triangle ABD equals to the base BD times the height AM over 2. Likewise, the area of triangle ADE equals to the base of the triangle that is DE times the height to the base that is AM over 2. Here we have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we got that after we cancel 2, we have the expression that dB times AM equals to DE over AM. We have AM in the numerator and AM in the denominator, so AM will get cancelled. And DB equals to 3 of it, and D equals to 7, so in conclusion we found out that the area of triangle DAB over the area of triangle AD equals to 3 over 7. Then we calculated in a second way the areas of triangle ABD and the area of triangle ADE. The area of triangle ABD, it can be also calculated if we take the base as AB. If the base is AB, then from point D we will go perpendicular to the base AB. So this angle equals to 90 degrees and this angle equals to 90 degrees. So DO will be equal to the I. So the area of triangle ABD according to the second calculation will be equal to the base AB times the height, that is H1 over 2. Again, the area of triangle ABD will be equal to the base AB times the height, that is H1 over 2. Likewise, we calculated the area of triangle AED when we took AE as the base. AE is the base, the height to the base is from point D. We draw perpendicular to the base AE, so this angle equals to 90 degrees, and this angle equals to 90 degrees, therefore K is the height. So we defined it as H2. So the area of triangle AED, according to the second calculation, will be equal to the base AE times the height H2 over 2. In the second calculation, the area of triangle AED equals to the base AE times the height H2 over 2. We have 2 in the numerator and 2 in the denominator, so 2 will get cancelled, and we left only with AB times H1 over AE times H2. AB equals to AE. So AB over AE will be equal to 1. So AB and AE will get cancelled, and we left only with H1 over H2. So in conclusion, we found out that 3 over 7 equals to H1 over H2. Now we will calculate the values of H1 and H2. Here in triangle, the right triangle, triangle AOK, sinus theta equals to H1 over AD. In the right triangle, triangle AOK, sinus theta equals to H1 over AD. We multiply this equation by AD and we got that H1 equals to AD times sinus theta. Here, H1 equals to AD times sinus theta. In the same way, we calculated the value of H2. Here, in triangle, the right triangle, triangle ADK, sinus alpha equals to H2 over AD. I will repeat again, the right triangle, triangle ADK, sinus alpha equals to H2 over AD. We multiply this equation by AD and we found out that H2 equals to AD times sinus theta. So we can write here that H2 equals to AD times sinus alpha. So here we have AD in the numerator and AD in the denominator, so AD will get cancelled. And in conclusion, we found out that according to equation number 1, 3 over 7 equals to sinus theta over sinus alpha. Then we found out the value of angle alpha. Here, we cross multiply this equation and we got that 3 times sinus alpha equals to 7 times sinus theta. And then we found out the value of angle alpha. We know that angle BAC from one side it equals to 90 degrees, but from the other side it equals to 2 theta plus alpha. Angle BAC from one side equals to 90 degrees, and from the other side it equals to 2 theta plus alpha. So from this equation we will conclude that 2 theta plus alpha equals to 90 degrees. That is to say, we can substitute 90 degrees by here we will subtract 2 theta from this equation. 2 theta plus alpha equals to 90 degrees, so we will subtract 2 theta from this equation, and we will get that angle alpha equals to 90 degrees minus 2 theta. That is to say, we can substitute angle alpha in equation number 1 by 90 degrees minus 2 theta. We did it, and we got that 3 times sinus alpha, and alpha equals to 90 degrees minus 2 theta, equals to 7 times sinus theta. So we have here equation number 1 states that 3 times sinus 90 degrees minus 2 theta equals to 7 times sinus theta. And we have the trigonometric identity that states that sinus 90 degrees minus x equals to cosine x. That is to say, according to this trigonometric identity, we will get that sinus 90 degrees minus 2 theta must be equal to cosine 2 theta. Therefore, we can substitute sinus 90 degrees minus 2 theta in equation number 1 by cosine 2 theta. We did it, and we got that 3 times cosine theta equals to 7 times sine theta. So here we have trigonometric identity for cosine 2 theta. According to this trigonometric identity, cosine 2 theta equals to 1 minus 2 sine square theta. That is to say, we can substitute cosine 2 theta by 1 minus 2 sine square theta. We did it, and we got that 3 times cosine theta, it is actually 3 times 1 minus 2 sine square theta, according to this trigonometric identity, and it equals to 7 times sinus theta. We open the brackets on this side of equation number 1, and we got that 3 times 3 is 3, and 3 times minus 2 sine square theta equals to minus 6 sinus square theta, that equals to 7 sinus theta. Here we added 6 sine square theta, and subtracted 3 from this equation number 1, and we got that 6 times sine square theta plus 7 times sine theta minus 3 equals to 0. So we have here a quadratic equation where the sinus theta is the missing variable. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula for x. X, it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, the missing variable is sinus theta, so x equals to sinus theta. The coefficient a equals to 6, the coefficient b equals to 7, and the coefficient c equals to minus 3. So here, therefore, we can put the data inside the formula for x, and we find out the value of sinus theta because x equals to sinus theta. So we get that x that equals to sinus theta, that is to say sinus theta equals to minus b, b equals to 7, so minus b is minus 7, plus minus square root of b squared minus 4 times ac over 2a. So b is 7, so b squared is 7 squared, 7 squared is 49, minus 4 times ac. A is 6, so it is minus 4 times 6, times 6 minus 3. So minus 4 times 6 is minus 24, and minus 24 times minus 3 is minus 72. So in conclusion, we got here plus 72. So inside the brackets we have 49 plus 72. Okay? And 2 times 6 is 12. So in conclusion, we found out that sinus theta equals to minus 7 plus minus 49 plus 72 over 12. 49 plus 72 is 121, and the square root of 121 is 11. So in conclusion, we got here two solutions for sinus theta. The first, actually we have here sinus theta equals to minus 7 plus minus 11 over 12. So we have here two solutions for sinus theta. The first solution for sinus theta is that sinus theta equals to minus 7 minus 11 over 12. And the second solution for sinus theta is that sinus theta equals to minus 7 plus 11 over 12. We'll focus on the first solution. Here sinus theta equals to minus 7 minus 11. Minus 7 minus 11 is minus 18, and minus 18 over 12 is minus 1.5. But because, so we found out that sinus theta equals to minus 1.5. but the problem is that sinus theta can never be equal to minus 1.5. Why? Because the values, the range of values that sinus theta can receive as a function is ranging from minus 1 to plus 1. And because of the fact that minus 1.5 is less than minus 1, that is to say, sinus theta can never receive minus 1.5 as a value. That is to say, this solution is the incorrect solution, so we cancel this solution, and we left only with the solution that sinus theta equals to minus 7 plus 11 over 12. Minus 7 plus 11 is 4, and 4 over 12. Here we divided both the numerator and the denominator by 4. 4 over 4 is 1, and 12 over 4 is 3. So in conclusion, we found out that sinus theta equals to 1 over 3. Okay? Then we focus on the right triangle ABE. In this right triangle, AB equals to AE, therefore triangle ABE is an isosceles triangle. We have AM that is perpendicular to BE. And because of the fact that AM is perpendicular to BE, it means that AM is the height to the base BE. Okay, and we have rule number 1 that the height to the base in an isosceles triangle bisects the base. So the height AM to the base BE bisects the base BE, that is to say BM equals to ME according to rule number 1. So if we define BM as Y, then from this equation Y equals to BM equals to ME, we will conclude that ME is also equals to Y. Okay? And so what is the value of BM? What is the value of BE? The value of the base BE? From the drawing you can see that BE equals to BM plus ME from one side. BE equals to BM plus ME plus from one side, but BM equals to Y, and ME also equals to Y. So in conclusion, BE equals to Y plus Y, that is 2Y. So from one side, BE equals to 2Y. But from the other side, BE is equal to BD plus DE. BE equals to BD plus DE. So BD is 3, DE is 7. That is to say, BE equals to 3 plus 7, that is 10 units. So from one side, BE equals to 2Y. From the other side, BE equals to 10. From this equation, we will conclude that 10 equals to 2Y. We divided this equation by 2 and found out that Y equals to 5 units. Y equals to 5 units, but Y, it is actually also equals to BM. So if Y equals to 5 units, then BM will be also equal to 5 units. And ME is also Y. So if Y equals to 5 units, then ME will be also equal to 5 units. So BM equals to 5 units and ME equals to 5 units. That is what we found from the isosceles triangle ABE, according to equation number 1. So then we proved that the right triangle AMB can go into the right triangle AME. Why those two triangles can go into each other? First of all, we know that AB equals to AE. It is given us as a question. Second, we just right now proved that BM equals to ME equals to 5 units. And we have AM as a common side that belongs to both triangles, so AM equals to AM as a common side. So we actually proved the triangle AME, the right triangle, can go into the right triangle ABM, according to side rule. And from the fact that those two triangles can go into each other, we will conclude that angle BAM is equal to angle MAE, according to the rule that corresponding angles that can go into triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding angles, that is to say angle BAM and angle MAE, will be equal to each other. So, in conclusion, we found out that angle BAM equals to angle MAE. So if we define angle BAM as Z, then according to this equation, Z equals to BM equals to MAE, we conclude that angle MAE is also equals to Z. So what is the value of angle BAE? From one side, angle BAE equals to angle BAM plus angle MAE. Okay, that is to say it equals to Z plus Z, that is 2Z. So from one side, angle BAE equals to 2Z. But from the other side, you can see from the drawing that angle BAE equals to here, theta plus alpha. Angle BAE equals to theta plus alpha from the other side. Again, from one side, angle BAE equals to theta plus alpha, from the other side, it equals to 2Z. From this equation, we derive that theta plus alpha equals to 2Z. We divided this equation by 2, and we got that angle Z equals to theta plus alpha over 2. But what is angle Z? Angle BAM also equals to Z. So, if Z equals to theta plus alpha over 2, then angle BAM will be also equal to theta plus alpha over 2. And angle MAE is also equals to Z. So if Z equals to theta plus alpha over 2, then angle MAE will be also equal to theta plus alpha over 2. So we can write down here that angle BAM equals to theta plus alpha over 2, and angle MAE is also equals to theta plus alpha over 2. Okay, then I copied the right triangle MAE in a new page, and we analyze the right triangle AME. So this is the right triangle AME. We just right now found out that angle MAE equals to theta plus alpha over 2, AM equals to H according to our definition, and we have already found out that ME equals to 5 units. So here, according to equation number 1, times theta plus alpha over 2 will be equal to ME over AM. Times theta plus alpha over 2 equals to ME over AM, but ME equals to 5 units, AM equals to H, so in conclusion we found out that according to equation number 1, times theta plus alpha over 2 equals to 5 over H. And then I copied the right triangle AMC in a new page, and we analyzed the right triangle AMC. This is triangle AMC. What is the value of angle MAC? It is very easy to find out that from the drawing you can see, it is very easy to see that angle MAC equals to theta plus alpha over 2, is the red line, plus theta. So in conclusion, angle MAC equals to theta plus alpha over 2 plus theta. Angle MAC equals to theta plus alpha over 2 plus theta. And AM equals to H according to our definition. And what is the value of MC? MC equals to ME plus EC. MC equals to ME plus EC, ME equals to 5, EC equals to X. So in conclusion, we found out that MC equals to 5 plus X. So in this right triangle AMC, the only missing angle is angle ACM. ACM is the angle that we are looking for. And we will find out the value of angle ACM according to the rule that the sum of the angles in any triangle is equal to 180 degrees. That is to say, this angle that is actually angle MAC plus 90 degrees plus the angle that we are looking for, that is angle ACM. In total, the sum of those those three angles must be equal to 180 degrees. We subtracted 90 degrees from this equation, and we found out that angle MAC plus angle ACM equals to 90 degrees minus 180 degrees minus 90 degrees is 90 degrees. We subtracted angle MAC from this equation, and we found out that the angle that we are looking for, that is actually angle ACM, equals to 90 degrees minus angle MAC. But we have already found out that angle MAC equals to theta plus alpha over 2 plus theta, so we can substitute angle MAC by theta plus alpha over 2 plus theta. We did it, and we got that angle MAC equals to 90 degrees minus theta plus alpha over 2 plus theta. But 90 degrees, what is 90 degrees? From one side, angle BAC equals to 90 degrees. It is given as the question. But from the other side, angle BAC equals to theta plus alpha plus theta. This is to say, it equals to 2 theta plus alpha. Again, from one side, angle BAC equals to 2 theta plus alpha. From the other side, angle BAC equals to 90 degrees. From this equation, we derive that 90 degrees equals to 2 theta plus alpha. That is to say, we can substitute 90 degrees in this equation by 2 theta plus alpha. We did it, and we got that the angle that we are looking for, angle ACM, equals to 90 degrees, that is actually 2 theta plus alpha, minus angle MAC, that is actually equals to theta plus alpha over 2 plus theta. Here we open the brackets, so here it will be minus, and the plus sign will become minus because we have minus before the brackets. Okay, so we have here 2 theta minus theta is theta, so we have here in conclusion theta plus alpha minus theta plus alpha over 2, and theta plus alpha minus theta plus alpha over 2 equals to theta plus alpha over 2. So we found out that the value of the angle that we are looking for, that is to say angle ACM, equals to theta plus alpha over 2. We have already found out that MC equals to x plus 5 and AM equals to h according to our definition. So in the triangle ACM, here tangent theta plus alpha over 2 will be equal to AM over MC. But AM equals to h, MC equals to x plus 5. So in conclusion, we found out that according to equation number 2, tangent theta plus alpha over 2 equals to h over 5 plus x. And according to equation number 1, we have already found out that tangent theta plus alpha over 2 equals to 5 over h. Then we created equation number 3, that is the combination of equation number 1 with equation number 2. That is to say, tangent theta plus alpha over 2 equals to h over 5 plus x according to equation number 2, and it also equals to 5 over h according to equation number 1. Okay? Then we found out the value of theta plus alpha over 2. The value of theta plus alpha over 2, it is actually theta, and alpha equals to 90 degrees minus 2 theta, so we can substitute alpha by 90 degrees minus 2 theta. We did it, and we got that theta plus alpha over 2 equals to theta plus 90 degrees minus 2, 90 degrees minus 2 theta over 2. Here we open the brackets, and we got that 90 degrees, and theta minus 2 theta is minus theta, and we have 90 degrees. 90 degrees over 2 is 45 degrees, minus theta over 2. So in conclusion, we found out that theta plus alpha over 2 equals to 45 degrees minus theta over 2. And we know that if alpha equals to beta, then tangent theta will be, if alpha equals to beta, then tangent alpha will be equal to tangent beta. Therefore, tangent theta plus alpha over 2 will be equal to tangent 45 degrees minus theta over 2. We have trigonometric identity for tangent 45 degrees minus theta over 2, that is actually the trigonometric identity of tangent x minus y, that is actually equals to tangent x minus tangent y over 1 plus tangent x times tangent y. So we use this trigonometric identity in order to find out the value of tangent 45 degrees minus theta over 2. According to this trigonometric identity, we will get that tangent 45 degrees minus theta over 2 equals to tangent 45 degrees minus theta over 2 over 1 plus tangent 45 degrees times tangent theta over 2. Tangent 45 degrees equals to 1. So in the numerator we will have 1 minus tangent theta over 2, and in the denominator we have 1 plus tangent theta over 2. So in conclusion, we found out that tangent theta plus alpha over 2 equals to 1 minus tangent theta over 2 over 1 plus tangent theta over 2. Now we have to find out the value of tangent theta over 2, and we will find out the value of tangent theta plus alpha over 2. And for tangent theta over 2 we have trigonometric identity. The trigonometric identity states that tangent theta over 2 equals to sinus theta over 1 plus cosine theta. And we have already found out that sinus theta equals to 1 over 3. And we have the trigonometric identity that states that sinus square theta plus cosine square theta equals to 1. We subtracted sine square theta from this trigonometric identity, and we got that cosine square theta equals to 1 minus sine square theta. We took a root out of this equation and found out that cosine theta equals to the square root of 1 minus sine square theta. sine theta equals to 1 over 3, so sine square theta will be equal to 1 over 9. So in conclusion, we found out that cosine theta equals to the square root of 1 minus 1 over 9. 1 minus 1 over 9 is 8 over 9. And the square root of 8 is 2 times square root of 2. The square root of 9 is 3. So in conclusion, we found out that cosine theta equals to 2 times square root of 2 over 3. And we have already found out that sinus theta equals to 1 over 3. Now we can put the data inside the trigonometric identity in order to find out the value of tan theta over 2. The value of tan theta over 2, according to what we have already found here, that tan theta over 2 equals to sinus theta, that is 1 over 3, over 1 plus cosine theta, that is actually 2 times root of 2 over 3. So here we multiplied 1 by 3 and then we divided by 3 in order to have a common factor with this expression. And in conclusion, we found out that tan theta over 2 equals to 1 over 3 plus 1 over 3 plus 2 times root of 2 over 3. 3, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled and we left only with 1 over 3 times 3 plus 2 times root of 2. Then we simplified this expression. We found out that tan theta over 2 equals to 1 over 3 plus 2 times root of 2, and we simplified this expression. So here we have here. So the expression is 3 plus 2 times root of 2, and we multiplied this expression by 3 minus 2 times root of 2, and then we divided by 3 minus 2 times root of 2. So in the numerator we have 3 minus 2 times root of 2, and in the denominator we have 3 plus 2 times root of 2 times 3 minus 2 times root of 2, and in the denominator we have expression that is very similar to the algebraic identity that a plus b times a minus b equals to a square minus b square. A is 3, so a square is 3 squares, 3 square is 9, minus b square. B is 2 times root of 2, so 2 times root of 2 square is 8. So in conclusion, in the denominator we have 9 minus 8, that is 1, and in the numerator we have 3 minus 2 times root of 2. So in conclusion, we actually found out that the value of tan theta over 2 equals to 3 minus 2 times square root of 2. Now we can put the value of tan theta over 2 inside the equation for tan theta plus alpha over 2, that is actually equals to 1 minus tan theta over 2 over 1 plus tan theta over 2. So it is 1 minus tan theta over 2, and tan theta over 2 equals to 3 minus 2 times root of 2 over 1 plus 3 minus 2 times root of 2. That is the value of tan theta over 2. Here 1 minus 3 is minus 2. So in the numerator we have minus 2 plus 2 times root of 2. In the denominator we have 1 plus 3 is 4. So it is 4 minus 2 times root of 2. So in the numerator we have here 2 times root of 2 minus 2. And in the denominator we have 4 minus 2 times root of 2. From the numerator we took 2 as a common factor, and inside the brackets we have square root of 2 minus 1. And from the denominator we took 2 times square root of 2 as a common factor, and inside the brackets we have square root of 2 minus 1. So we have square root of 2 minus 1 in the numerator and square root of 2 minus 1 in the denominator. So square root of 2 will get cancelled. We have 2 in the numerator and 2 in the denominator, so 2 will also get cancelled, and we left only with 1 over square root of 2. So in conclusion, we found out that tan theta plus alpha over 2 equals to 1 over square root of 2. And according to equation number 1, tan theta plus alpha over 2 equals to h over 5 plus x, that also equals to 5 over h. Now, when we just right now found out that tan theta plus alpha over 2 equals to 1 over square root of 2. So here we can derive from equation, the long equation here, that 5 over h equals to 1 over square root of 2. We cross multiply this equation and found out that h equals to 5 times root of 2. Then from this long equation we derived this equation in the red color, that h over 5 plus x equals to 1 over square root of 2. Because multiplied, first of all we put the value of h, that is 5 times root of 2. We substitute h by 5 times root of 2. and we got that 5 times square root of 2 over 5 plus x equals to 1 over square root of 2, because multiply this equation, and we found out that 5 times square root of 2 times square root of 2 equals to 5 plus x. Square root of 2 times square root of 2 is 2, and 2 times 5 is 10. So in conclusion, we found out that 10 equals to 5 plus x. We subtracted 5 from this equation, and we got that 10 equals to 5 plus x. So we subtracted 5 from this equation, and we found out that x equals to 10 minus 5, that is 5. So in conclusion, we found out that the value of x, that is actually equals also to line segment CE, equals to 5 units. I'll repeat again, the value of line segment EC, that is actually also equals to x, is 5 units. Okay? The answer to the question is that value of line segment x is equal to 5 units. Okay? Thank you very much.